And good morning. Just before I kick off, let's make sure that my audio is working. Can everyone hear me fine? I'll just give it a sec, see what my delay is today. Not too much. Morning Shrey, how's it going? Say good morning chicken, she just walked in the room, but she's over there for the moment, you don't get to see her yet. Not until she decides to come around here and say hello. Alright, everyone can hear me. That's great. I hope everybody is enjoying this beautiful morning today. Looks like a really nice day outside. Might go for a walk later or something like that. If you are going to go outside and you happen to live near UNSW, don't pat the fox. Frankie is not a pet. You can pat your own cats if you have a cat like Chicken or a dog, but don't pat Frankie the fox, who is on campus at UNSW. Yeah, several people get bitten by Frankie, and then have to go to hospital to get tetanus shots and stuff like that. So don't necessarily pet Frankie. Frankie bites nearly everyone that pats it. So Riley, yes, cute. Look at photos of Frankie. Don't pat Frankie. So I don't know if anyone else has heard of this. It's just like the funniest thing that's happened over the last few days. Is a fox moved in to campus. I always like joke at the whole the thing about when we all went into lockdown for the COVID stuff, and it was just like nature returning to the world, and it was yeah, and so this is our little slice of that, with a single fox moving into campus, and then in the first night it decided to take residence on campus. It bit like 3 or 4 people, one of which was one of your tutors, and so I laughed a lot when that happened. Not that much, but a little bit at least. And someone saying, why did we make the labs this week so hard? I tried to... Okay, so this is an issue, I think, that I probably could have put Order 3 in last week, because it's an if statement challenge. And I probably could have put the spiral stuff in this week. But I kind of love them both because they're really interesting. And because I hadn't put the Order 3 stuff in last week, I had to throw it in this week. As they're challenges, you don't have to do them, and I'm happy if they just for people who are happy with the material as such, and are confident with what they're doing, if you just play around with them and then see if they open up your mind a bit to some interesting ideas, but you don't have to complete them. All right, just remember they're challenges; they're not super necessary or anything. Yeah, as Shrey is saying, yeah, some of them are super hard, and usually they're just there to open up your mind. Oh, Terry, that's pretty awesome that you managed it with the Challenge 2 version. And then, yeah. So that's the interesting thing about Order 3. If you want the super challenge version of Order 3, then go to the second Order 3 challenge, do that, and hand that one in for all of them. Because you notice the functionality is the same for all 3 versions of Order 3 that are in the lab. But the difference is the limitations of what you're allowed to use. So Order 3 is not... That's the reason why it's in challenges and not in the extra bits are not in the regular lab, is they're not the way that we normally program. Order 3 is there to teach you that there's other ways of thinking about how programming constructs work. It's an idea of getting you to think outside the box. And so it's a good one for that, because what we need to realize the more programming we do is that everything we do in programming is just using tools. And using tools in different ways is an important way to think about things. Oh, hello. Well, we've got a friend to say hello. Alright. There's your little morning chicken. She was sitting up in the window up there. So I've got natural light today, so I'll look a bit different. but she was just sunning herself in the window, and she's come past to say hello, and then she'll be moving on, I think. Echoic is saying, yeah, there were lots of ifs for Order 3. That's totally fine. Um, yeah, everyone can go now. Chickens appeared. Okay. Let's get into the lecture itself, because we've got a bunch of stuff that I want to cover today. So let's have a quick look at what we did last week. So last week we were continuing what we'd done with if statements. We did some more complexity of the if statements, where we added multiple questions together using the logical and relational operators that we'd been working with. So we were able to ask questions about things like the more complicated dice range and things like that. But then we also had a look at what it means to break a problem down into its parts, and what it means to assess different potential solutions to problems. So we're trying to think about answering questions, not just as getting an answer that's correct to a question, but realizing that many questions and many problems that we're going to approach have many different potential solutions that are all correct. And correct is such an open way of thinking about things, because if you only want things that are correct, you can end up doing some really weird stuff. Like the example that the brutal example that I had was that if a student asks me to help make sure their code compiles, I can guarantee their code will compile by deleting everything between the curly brackets of int main. And if doing so, if I have deleted everything between the curly brackets, then yes, there's no program anymore, but I will have solved the problem in that it will compile. And that's a very, very mean thing to do. But if you don't think about problems carefully, you start solving them like that. So we would need to think about, it's not just a correct answer, it's about trying to think about the most appropriate thing for what people need out of a program. And that becomes a much bigger and actually very interesting problem once you get much deeper into computer science. We also looked at while loops, and while loops are super important because they're our ability to repeat code. It's possible, but also reasonably rare, that we're going to create a program that doesn't have some kind of looping in it. Because anything that doesn't have looping has probably got a whole bunch of branching if statements and stuff like that going on. But otherwise, a lot of the stuff that we're going to write from here on in is going to need us to do at least something more than once. A lot of people saying someone's happy that functions are appearing, someone's looking for hints on challenge 1. I think what Terry's answer there is good. I think you gotta turn it over for a little bit first. But it depends. This is you may have been working on it all weekend since it was released, so you could ask some questions on the forums if you want to, because the tutors answering the questions on the forums are going to know exactly how much they should give out as a hint, so that you still get a chance to work on the problem. If we start kind of discussing it amongst ourselves a lot, we might end up in a situation where someone gives you too much of a hint, and then you don't get a chance to learn anything from it. So I say forums is the best place to talk about it. And as Shrey is saying, don't spoil them, because a lot of these things, I mean, the learning experience is about working with it. Like, honestly, a lot of the challenges, I don't even care if people submit them or not. I care if they look at them and they see if something's interesting there, if something sparks an idea in their mind. And also, everyone's challenge level is different. So if the challenges are impossible for you, you don't have to do them. If some of the standard exercises are challenges, because it is going to be that way depending on people's experience with programming. One of the things about 1511 is, while it may be the first programming you do at UNSW, it's not the first programming for everyone. So we get a really wide range. Some people have been doing it all the way through high school. Other people have not done any programming at all. And there's no measure that says that someone who's been programming all through high school versus someone who has never done any programming before. There's no measure to say which of those two people is going to be better at programming by the time they get to the end of their computer science degree or whatever degree they're doing. Because I think there's a lot of data science, software engineering. There's lots of different degrees that are going to have computer programming, I guess, as one of the core elements of the degree. There's nothing to say that that one of those students is going to be better than the other, because once we throw you in the deep end at university and push you to this kind of professional level of programming, you can rise from any situation to that. So it's not really important which part of the lab is a challenge for you. So for some people, decimal spiral is the challenge, because that's the hardest thing that we have to throw at you at this point in the course, and it is hard. It's hard as hell. I can't even remember off the top of my head how I solved it last time. I know that there's different ways. I'm being careful not to say anything about it. But for some people, just like writing legal C is the hard thing for the moment, because it's a language you've never seen before, and it's kind of like, if I just give you French, and I'm just assuming that not many people speak French at the moment. If you do, just think of another language. If I was to give you French and say, okay, I'll give you 2 weeks, and then I want you to be reasonably fluent in it, I want your grammar to be perfectly correct when you're writing it, people would be like, oh, that's not going to happen. It's like, yeah, I know that's not going to happen, and so that's why we're just going to keep practicing. We're going to do exercises and stuff like that. David saying, is it okay to not do all of the standard exercises and pass the course? Yeah, well, when you consider the labs are worth 10, I know I'm supposed to know this, but I change it every now and then, so I forget exactly how much the labs are worth, but I think the labs are worth 10% of the course. So if you're pretty confident about how you can do with other things, you don't have to hand in all the labs. I would suggest, though, that the 10% of marks for the labs is deceptive. Because while they may only be worth 10%, if you don't do any of the labs, your chances of getting really high marks in other parts of the course are really low. Because the labs are the things that give you the practice and set you up for doing the harder things. So yes, it is technically possible to not submit all of the labs and still pass the course. I mean, we even have a rule in the labs that in case someone gets sick and misses a lab and stuff like that, or you just have a really bad week with assignments for other courses, so you don't do labs one of the weeks, we only mark the best 6 out of 7. Wait, that's weekly tests. The best 7 out of 8 of the labs that you hand in. Yeah, because there's 8 labs that you hand in. The first week's lab we don't mark because that's an intro. That's just getting us up to speed. But weeks 2 through to 10, not including 6, no lab in week 6, we will mark your best 7 out of 8 and give you the mark out of that. So even if you miss one entirely because you just, life gets in the way, we understand. We still only mark the best marks that you have. Yeah. Okay. James asks an interesting question there. When do the weekly tests come out? Normally, the weekly tests will come out on Thursdays, and they'll be due at 5 p.m. on a Thursday. I'm not doing that this term because we have a lecture from 4 to 6 p.m., and I don't want the weekly test to be due in the middle of the lecture, because I think that's going to make people not want to come to the lecture and do the weekly test instead. I haven't decided exactly how that's going to work, but I'm thinking it's most likely going to be a release on Friday and a due date on Friday rather than on Thursday, so that you can just sort of spread out your deadlines through the week rather than having them kind of on top of each other, so you don't have to do your lecture and your weekly tests sort of conflicting with each other. But I will let you know how that's going. I'll either release it Thursday night and make it due on Friday, or I'll release it on Friday, make it due Friday, make it exactly a week's worth of work. We'll see how we go. Okay, Claude's asking what the regular labs are when I'm talking about that. I'm talking about the lab exercises. The ones that are not challenge exercises, they're marked in the labs as pair exercises. We used to do them in pairs when you're in person because it's really easy to put people together physically. You can look over each other's shoulder on the keyboard and stuff like that. the way we're doing it now, depending on your tutor, some tutors are actually still doing pairs, but other tutors are doing things with little breakout groups in Blackboard Collaborate, so you can go into breakout groups and discuss these questions with other people. So the point of the regular labs is it's not super individual. Like, you don't have to complete it all yourself. It's a point for you to discuss with other people, and so you can learn from the way other people are coding. You can show other people code. You can learn from teaching other people how to solve these problems as well. These regular lab exercises, as in non-challenge lab exercises, are designed for you to get a bit collaborative with it. It's not meant to be something that you're forced to do alone. So you can go into the lab time, you can talk to people, you can talk to your tutor about it, you can work on the problems with your tutor as well. So it's meant to be reasonably open, those ones. Arian, we probably won't do a release and a due date on a Saturday because I don't usually work on Saturdays. I try to take at least one day off a week. But even if it is due on Friday, it's only a 1 hour exercise. So if you want to, you can always just not look at it on Friday and then do it on the Saturday instead. And then you've got a whole week to look back on it if you want to. Before the due date. So up to you. Anyway, I'm not going to organize your time for you. I think that's something you can do. All right, into the lecture itself. I do appreciate the fact that we're live streaming, so I can actually talk to people and answer questions and stuff like that. But we should actually get into the lecture. So Mingji Li is saying the situation seems all the labs are individual work, and I know it's tough because it's online. But the trick, if you don't want to have to do all the labs individually, is go along and spend the full 2 hours in the lab time. Because if you do spend that time on it, there is maybe, not 100%, definitely enough time in the lab itself to do the majority of those exercises. And even if no other students turn up there, you can just talk to your tutors about it, and you'll probably be able to get a whole lot of like interesting discussion with them if you want to start the discussion. It's a bit fiddly because it means that you're doing it online, so you've got to be okay with using your microphone if you want to, sharing your screen and stuff like that. Anyway, let's get into the lecture itself. Okay, so the things that I'm covering today. We're going to talk about code style. So for the moment, I've just been writing code. And the only thing we've been thinking about is like, is your code going to work correctly or not? Today, I'm going to do a little bit of a deep dive into what it means to make your code reusable, what it means to have your code be able to be easily read, so that someone else can use it, so that you can find your mistakes more easily and things like that. And we're going to look at code reviews. We're going to start doing code reviews next week in the tutorials. And a code review is the idea that we're going to look through each other's code and be able to give each other advice on it and learn from each other about seeing each other's code. There's a few different ways we can do this. And then we're going to start with another technical topic, and that's functions. I'm not going to give you everything that I want to talk about in functions today, but I'm going to explain to you some of the simple bits of what functions are, and how we can use them to sort of make some of our code a little bit more easy to use and easy to handle, and it helps us to not have to repeat code as much to have functions. We'll see if we get through all of this today, because I know the first two topics are the things I really want to cover today. Functions sort of overflows, because I'm going to show it again next week with some other stuff as well. So whether we complete everything on functions today or not is we'll see how we go. Okay, so a bit of a recap on while loops. While loops have a specific syntax, and we've seen this syntax already. It's the word while, some brackets with an expression in it, and the expression is the one that gets tested every time we loop. And then the curly brackets is what runs every time we loop. We looked at two ways of stopping while loops. One was to stop after we'd done it a certain number of times, and that was the thing where we used a counter or a variable called I, which is an iterator that will decide how many times it runs. The other kind of while loop was the one that said we will just keep running until we flick a switch, in a sense. Like we say, okay, under a certain condition we'll stop running. And so I've shown you the basic format for both of those, and if those are the only ways you remember using a while loop, they will serve you for a great deal of the things you need to do. The only other while loops that you may need to learn about, and you'll learn about these in the labs and the tutorials, is what if we want to do, say, all numbers between a certain range, and then we'll do something different with our while loops. But that's just a slight extension on these styles. One of the tricks with while loops is we can always create a loop. It's always easy to make a loop start, but every time we create a loop, we need to remember how we're expecting it to stop. Because if we don't know how we want the loop to stop, then our program may not end. Just remember that if you do need to stop it while it's running and your program's just kind of spinning forever, Control-C is the command in Linux that will pause a program. Well, actually, it'll cancel a program entirely. I'm pretty sure that's why it's Control-C at that point. It's actually the same command as copy for copy-paste, but while a program's running, it just does different things. That will stop the program, and if you've compiled the program with DCC, the program that we provide to translate your code, the compiler translates your code from what we can see as humans to what the computer can run. If you Control-C it, it'll stop and it'll tell you where it was up to, and it'll tell you what the variables looked like at that point in time, which will probably help you find out what exactly the problem is. If nothing else, you'll probably know which loop you're stuck in at that point. Oh, I think Shrey is answering questions there, so that's good. I won't go too far into things. Okay. So, some examples of the code that we looked at previously. If we want to run a loop an exact number of times, I can set up an integer that's outside the loop. Remember, what goes on inside the curly braces stays inside the curly braces. If I create a variable inside the curly braces, it will be basically destroyed when I hit the end of the curly braces. So, if I want a counter that changes value, but will keep its value regardless of whether the loop is running or not, I want to create it outside the curly braces of the loop itself. So since this is outside, I make changes to it and the values change, but it won't be cleaned up and removed every time we hit this closing bracket here. So the I is 0 and that counts through to 9, and the code in here will run exactly 10 times. The other way we could do it is using this thing called a Sentinel variable. The names are not super important for these things, like a counter variable and a Sentinel variable and stuff like that. You don't really need to worry about the names. It's more about learning how to make something work. So I can have an integer here that just records whether or not we should stay in the loop. And this says 0 for end loop, saying don't end the loop. And so while we're not supposed to end the loop, we'll keep running it. But at some point we could change this and say, okay, now end the loop. So I've got a little condition in here which is just asking whether a number is odd or even, and then it prints it out, and it'll only end the loop if it sees an odd number. So this is just one other way to end the loop. This loop could potentially run forever, because if we keep putting even numbers into this thing, it will keep looping, but it'll end on a certain condition. So the difference is, this is a very specific number of times that this loop will run. This one could run any number of times, but it has a certain condition under which it stops. Okay, code style. Ooh, covering up my memes. As you can tell, I am quite partial to cute cats, especially this one because it puts on the glasses and it loves them. So I said that in one of the early lectures, and I think I repeated it again, that when we're writing code, we're writing 50% of our effort is being put into getting the code to run on the computer. But when we're writing code in a genuine sense, and this is, we're thinking about writing code professionally and stuff like that, we're spending 50% of our effort trying to make sure that the code is usable for humans. There are a few reasons why we do this, and I've got some of the reasons here. If it's easier to read, then it's easier to work with, right? If it's easier to understand, it means that we're going to make less mistakes. And it's really funny because there's a bit of an investment here in doing this. Like, it takes a bit more effort to write code that looks really nice compared to writing code that doesn't look nice. But what we get out of this is that even if that is taking more time and effort, we're going to get faster overall development time because we're going to make less mistakes, and we're also going to be able to find our mistakes more easily, the more easily we can read our code. So, oh my god, Charles says he wants to use continue. And people are talking about for loops. If you really want to use for loops and you know how to use them, you can use them. They're legal C. We're not going to teach them in this course because there's no reason to teach two kinds of looping in an introductory course, because for loops and while loops can functionally do exactly the same thing. So there's no reason to say, okay, here are two completely different ways to write the same thing. I always teach while loops because you can read them from top to bottom, and it's easy to understand what's going on, whereas a for loop requires you to just think a little bit more differently about how to set them up and the order that the operations happen inside the loop. I do understand, because I think that as an experienced programmer, I tend to make less of particular kinds of mistakes with for loops than I make with while loops, but I still think that while loops are much clearer to read than for loops. So that's why in the choice between the two of those, also there are things that while loops do much neater than for loops do. So the choice of which one to teach, if I'm only going to teach one looping style in the course, then it's going to be while loops, because they're the simplest and most generic of them. Yeah, Shrey's saying the same thing. For loops do not exist. They do exist, but anyway. I tend to use for loops a lot more in particular languages and things with particular data structures. They make a lot of sense. But I'm not going to talk about that because we're talking about code style right now. Sorry, I get distracted by the chat sometimes, but that's okay. I think the whole point is, like, the idea of me live streaming lectures is I'm supposed to be interacting with everyone. But I'm going to go back to code style. Okay, so the trick is we are going to be coding so that we help ourselves in the future, and so we help the people we're working with as well. So I don't just want to say to you, okay, write with good code style, because I haven't explained what good code style is. So I'm going to break this down into parts, and I'm going to say these are the first things that we're going to work on to make our code very readable, and also make our code easy to understand for ourselves and other people. In the end, it means we can see what's happening in the code as well, so it's easier to write code in amongst code that's already lined up nicely. So, a couple of things that we're going to look at. Indentation and bracketing. We're going to make sure that with our brackets and our indentation, we can see exactly which code is inside brackets and which code is outside brackets. We're going to look at the names of our variables and functions. When I say names of variables and functions, I have not yet shown you what a function is. That's coming today, but I put this in here anyway because it's really, really soon. We're gonna start talking about functions like within the next 2 hours. So I put that in anyway. These are the bits that we name, and when we name them, we're naming them to describe what their purpose is, and so that a human can understand the purpose of an object that we've created. So it's important that we give it a name that's human readable. Repetition or not of code. If we copy-paste code, so you saw the the hilarious copy-paste thing that I did when we were doing looping code before. We really don't want that kind of thing to happen. But it's not just to be able to put stuff in loops. we would use functions actually to get rid of some of the other repetition in our code that we will talk about later. But still, we don't want copy-paste of code as much as we can help it, because the more we copy-paste code, the more we leave ourselves open to the possibility of having two different versions of the same code in our code file, and that can really, really mess things up. And I think that was really, really beautiful. I would love to say I did it on purpose, but I didn't. But it was really, really beautiful that I had two versions of dice checking. That was at week 1? That wasn't week 1. That was week 2, I think. Yeah, with the two versions of reading in die 1, reading in die 2, and I edited the wrong one. And then I had no idea why it wasn't working. It was like, I changed this. Look at the code. It's fine. Because I had the same code in two different places, I'd confused myself as to where I was. So even if you've been programming for years and years and years, repeating your code can cause you problems. Clear comments. If we describe to people in the comments what's happening, it's much easier for people to read the code. Depending on what it is you're writing and how it works, sometimes it's really easy for someone else to know what your code is doing by actually just skimming through and looking for the comment text. So if we're using the standard gedit that I was using, then I just look for the blue text and I go, okay, what's this person doing here? What's this person doing here? I've got a whole paragraph of code. I don't really want to read the whole paragraph of code, but I've got a one-liner at the top that explains what that paragraph of code does. We can use white space in our code as well to spread out these paragraphs so we know exactly that, like, okay, here's one little topic that I work on with some code, and then here's another with a line of white space in between so they're separated. A lot of little things like that, and it's the same way that you might write a report or something like that, like a technical report or an assignment for a course that's in written language rather than code. You would still separate things based on subject matter. We can do that with our code as well. So you would have seen this. This is the thing, I'm talking about stuff today that I've been sneaking in and I've been doing the whole time, because I'm not going to teach a course where the first 2-3 weeks I don't write good style. I'm going to make sure I'm writing good style code, and then now I'm going to tell you the details of it. And so I've been separating things in paragraphs as well. And I think I mentioned it once or twice while I was doing it. Another thing is consistency. What we try to do is we try not to switch between different styles of doing things. So there are two different styles of bracketing that people tend to use, and there's also two different styles of variable naming based on multiple words in a variable that people use. If you're going to pick one of those styles, I suggest you stick with it through the entire program, because if you go back and forth between them, it'll confuse people a lot. So let's have a look at a program that has some poor code style. I'll say this is one I prepared earlier. This is one I wrote up a few months ago. I can't remember if I've actually downloaded this onto my VLab yet, but let's have a look at this code. This is in the lecture section of the course website at the moment. If anyone has looked at it in advance, it will be super interesting. You'll get to see potentially some of the hardest to read code that I can write. What are we, week 3 here? This one. Okay, I'm going to download that. I'm just hiding the next the next. I don't want to scroll any further down because I've got stuff that I haven't made public for you yet. Let's save that. I'm going to put it in my COMP1511 directory because I haven't made a lecture 5 directory yet. Alright. COMP1511 in here. There's my code style bad. I'm going to make a directory for today's lecture. And I'm going to move my code style bad into my lecture 4 directory. Then I'll change directory into lecture 4, do a listing and see, did I just move into lecture 4? I was just like, which lecture are we in? No, we're in lecture 5. Okay, I'm going to move code style bad into, go up 1 level, ... and then lecture 5. CD, change directory, go up, and then into lecture 5. Alright, now it's where I wanted it to be. Okay. Shrey saying I should show some of the gross tutor code we discovered. What would be really funny is if I showed you some of the code that runs COMP1511. COMP1511 has code that runs how the subject works, and if you were to piece it all together, it's roughly the size of, I don't know, I would say 50 to 100 of the assignments we ask you to do. So if I ask someone at a first year computing level to build the infrastructure to run a subject like COMP1511, so I'm talking like what runs the auto tests, what runs the release of tutorials, what pieces together the HTML of the course website and all this kind of stuff. I think it would take someone at a first year level of programming 2 or 3 years just to build the infrastructure. You'd learn a lot. But if I was to show it to you, like the funniest, the way I like to talk about the infrastructure in the back end, some of it's really messy, is that it's the Millennium Falcon. So I don't know how many people know Star Wars. If you know Star Wars, you will know of the ship called the Millennium Falcon. It is a ship that has been rebuilt, repaired, modified so many times that it just breaks every time you try to make it run. And it has a cockpit full of switches. There's all these switches around and levers and stuff like that. And when I first sat in the cockpit for it, I did not have any idea what most of these switches did. So what I would do when I wanted to like make a certain tutorial release is I just flick random switches and hope. And I've slowly learnt how to actually fly this ship that's super confusing and made out of random parts. So it's always really funny because this is something that you're going to get from all of your lecturers, and anyone who's ever taught you has always, at some point when they taught you something, they've said, look, I'm going to tell you how to do things properly, and I'm going to kind of try to hide the fact that I don't always do things properly. So I don't have a spare year or two to rewrite the COMP1511 infrastructure, so I just kind of continue piloting it and hope that it's going to keep flying. But when we do have a chance to rewrite things, we rewrite things well and we clean them up. But it's not always 100% possible. People are making jokes in there about the Millennium Falcon and stuff. And yes, and people are noticing that there are references to the Star Wars saga in my slides. There are more of them later on as well. Anyway, let's have a look at code style bad. This is my favorite piece of code to show all year. Okay, at least I have a comment here. Please bear in mind that this is an example of poor coding style. This is not an example of how you should be using code in your learning for COMP1511. So, quick look through this. I can see a line here that makes sense to me, includes standard input output, and I've got this. Okay. Now, I just want to say that I have, in the past, done things like gone to help sessions, and someone has put something like this in front of me, and I've said, I'm not sure if I'm going to be able to help you with how your code runs, but one thing I can help you with is massaging this into a state under which we can actually both understand it, and then maybe you'll see the problem without needing me to point it out once we do that. Oh, see Shrey. Charles, how'd you get my dice check.c? Leon says, looks good to me. Okay, so you're all fired. Um, okay. So, some of this, okay, some of this one, check this one out. This is from, like, I didn't make this one up. This is from, who was it? I'm not gonna name and shame. I was trying to remember where I was working at the time. Actually, I think this was in when I was doing my PhD. In the PhD lab, we had a line of code that didn't appear to do anything, and it really didn't. Like it should have had no effect on the code, but it had this comment above it. So obviously, those of us who knew what we were doing were like, no way, I'm going to remove this line of code. It doesn't do anything, and the whole project broke when we did that. And we still to this day. This is like, okay, this was like 3 PhD candidates. So 3 of people you'd consider to be the top students at a university. People who have finished an entire honors degree at a high enough level to be allowed to do a PhD could not figure out why this one line of code couldn't be deleted. And so the comment ended up staying. And it's just such, yeah. So it's like, I saw someone else put a comment in saying, here be dragons, and then put a mess of code afterwards. Okay, so let us think about this. All right, so we have a look at the code. I've shown you a bit of that code there. The question then is what went wrong, and this is something that's important, right? Because yes, we can say this is a massive mess, right? But what we want to think about is what are the specific things that we can do? What are the specific things we can change? Because I think one of the things that we're always going to get into, and this has happened to a lot of people when we first join a new company and they say, okay, here's the code base. We hired you specifically to fix this. And then they will drop this on you and you'll say, you know what, this is too much for one human to handle. And so what we want to do is actually kind of say, okay, we're going to fix small parts of this. We're going to fix one bit at a time, or we're going to work our way through it. This is the same as what's potentially going to happen to you in less than a week's time when we release the first assignment, and people are going to read the big document, which is the whole assignment, and they're going to get massively bamboozled by the amount of stuff you have to do. And the trick is to find the easy bits, pick off the easy bits first, focus on fixing things, and then see how we go. So what we want to do now is we want to... Someone said, I don't need this job anymore. Look, I'm not gonna lie to you, that kind of thing has happened. People are like, hey, do you want to work on this project with us? It's an open source project, we're all just going to chip in together. It's like, yeah, sure. Give us a link to your repo, have a look and go, oh, I've got other things, I'm really busy, I'm sorry. And they're like, what do you mean? You said you could do it. It's like, no, I'm just really busy, I'm going to run away. It happens. But the other thing you can do is you can actually go in and go, all right, I'm going to limit the amount of work I'm going to do, but I am going to try to fix this. So, okay. Before I just jump forward to that slide, spoilers in there. Let us open up. This is opening up to everyone. Tell me what you think is wrong with this code in the live chat. If you're going to answer in the live chat, just at me in the live chat. So at MarkG in the live chat. I think you can auto-complete that. And tell me any of the issues that you think. Usually I would do a show of hands here, but I figure we can just do it in the chat. It's actually easier in the chat. So any issues that you think you can see here, try to isolate them into smaller issues and we'll fix them as we go. Yeah, people talking about lab partners and stuff. We haven't really been doing the whole specific lab partner thing while we've been fully online. Having said that, we can still work with people who are in our labs at a time. Okay, Tiara is saying formatting and comments. Jasmine is saying indentation. Roy is saying constants, not all uppercase. Matthew's saying brackets, white space, statements on the same line, unreadable variable names, unhelpful comments. Jen saying indentation, spacing. Two people saying spacing. Riley says indentation variables initialized in one line. Max is saying indenting after if statements. John saying no white space. A lot of people saying indentation. Charles said too many comments. Charles is going to get in a lot of trouble. I'm going to find who's tutoring you, Charles, and I'm going to get them to have a chat. No, I don't mind. I know, I understand. Charles is joking. Alright. Lots and lots of stuff. Okay, I'm going to stop because we've got like heaps and heaps of stuff here. Okay, so let's look at some of these things. Let's even look from top down some of these things. Look at this one here. Constant is lowercase. So if constant appears, I don't even know if it appears in here anyway. I can't find it because it's not all caps. Ah, there it is. This looks like a variable now. I could potentially try to change this, and so that would be really fiddly. So I'm going to say constant should be constant, but it shouldn't be constant. It is a constant because it's hash defined as a constant, so this word has no meaning. So I'm not saying what this 7 really means. What this 7 actually is a target value. And I'll change this one to target value and hope that doesn't break anything. I might do a control F. Control F is for find, and I'll look for constant. It's down here. Right. I'll change this one to target value as well. Now, immediately, we know that this is checking against target value now. So we've already made an improvement. Okay, a lot of people talking about indenting. Yeah. Okay, so I can't tell what's inside what brackets and what's outside of what brackets. So what I'm going to do is I'm going to start moving everything to exactly 4 spaces if it's inside this brackets. And then I've got a bracket here. I don't want stuff on the same line because it's really hard to read. So there. This bracket closing here is really hard to find because we don't usually scan to the end of line for that. Okay, immediately we're getting the idea that if I do my indentation correctly, these things are inside the main, and then there's a new set of brackets here. These things are inside this new set of brackets. So just immediately, without even looking at what's on each of these lines, I can already see what's going on. Riley, but it is a constant. Again, that's exactly the same thing as where I'm saying I could give you the truth, but I could give you the truth that is completely useless to you. So I could give you an answer to all of your questions, which is like, Mark, how do I make my code work? And it's like, well, the code's technically going to work if it runs. So if you delete it all, it works. But anyway, what I'm seeing here now is I can see what's inside what. Even though a lot of these lines are things that I would consider to be really, really bad code style, if I don't read the lines itself, I can see the structure of the program. So I'm starting to get a good idea of what's going on. Oh, Catherine's asking, does this code run at the moment? That's an interesting question. I'm gonna clear those errors. Oops, it's not called dice. Code style bad. I think it's the dice checker. Oh, wow. Six-sided dice. There's a 5 and a 4. It does run. So that's interesting that it does run. What I should also say, there's an Easter egg. It's not an Easter egg, but somewhere in here there is an error that is making the code not run exactly correctly. I will let you see if you can find it. So this error is really, really easy to find if the code is written properly, and it's really hard to find the way that it's written at the moment. So it's really interesting. Max is asking if we can initialize multiple variables with just one use of int. We can do this. This is technically allowed. So this is correct C syntax. I can say, I would like a bunch of integers and here are their names. However, as people said, these names are really bad. What's X and what's A and what's B and what's Y? Why they're not even in order. Like if I was going to do this as a mathematical program, it would be like X and Y would be together and A and B would be together or something. Because why is it X, A, B, Y? And what even do they mean? So this is an example of if we have variable names without meaning, then I don't know what I'm doing. It appears in this scanf, and this scanf on the end here, let me show you how a programmer will read a program. I will start here, and I'll read this. I will go downwards, line by line. I'll read the structure of the program. So I'll think this thing is just printing out two things and then going into an if statement. This here, and people did point this out, multiple operations on one line is really, really scary. Because the chances of losing this operation because we scan downwards and we read are really, really high. So let's just move this. If I move this, now I have a situation where I go, okay, print, then scan, then print, then scan. I'm getting better information now. In which case, I'm starting to understand that if I ask them to enter how many sides are on the dice, so this isn't exactly the same dice check. Because I don't think we had code for changing the number of sides on the dice, but it's similar. So that means that this X is actually the size of the dice. So what I might do here, I'm going to press Control H, which is a replace. This is potentially dangerous, so be careful with this. But what I'm going to do is I'm going to search for anywhere where there's an X in this, and I hope there's no X. The X is a very bad thing to search for because it could be part of other words, but I think it'll probably be okay. But I can go replace X with dice size. I can try to match entire word so that oh no, that doesn't make any sense for a single letter to match an entire word. So X and dice size, this will say anywhere I used X, it'll change this to dice size, and I'll go replace all. Close that. So dice size, dice size, dice size, dice size, dice size, etc. So if I want to, I can go through this whole thing and change the variables I need to. I'm not going to do all of this now because I don't really have time. There you go. There is an example in the word example, and another one here about how doing a global replace, just replace all X's with the word dice size, can get you into a lot of trouble. So I did want to show that we can do a find and replace within our code. That's Control H, or we can go here, search, find, and then here's the one that replaces things. So sometimes when we do this, we're going to want to go through every single word that we're going to change and make sure it's the right thing. Otherwise, we can change things that we weren't intending on changing. Having said that, we could go through, fix up all of these variables, and make sure that they're the correct variables. Ray saying we can use a different editor and search with different methods. Yes, we can. There's many different editors that we could use that would be able to replace these variable names in different ways. Having said that, what we would usually want to do is to not be in a situation where we're going to do a global replace on variables and just pick the right names to begin with. As I said before, the right names for variables is usually choosing something that makes sense in terms of what is the variable for, like what is its function. I shouldn't use the word function. Function's about to be a keyword for something else. What is its purpose? And how do we distinguish it from other things in the program? David's asking if there are other programming languages that don't use English. Yes. I can't remember. I can't remember off the top of my head if there are any, but I think that there are some. Having said that, a great deal of the computing industry was built on the outset in the UK and America. So a lot of the programming languages used were developed in the US. So we end up using a lot of English, even to the point where we use American English. So I've done a lot of graphics programming, and color in graphics is always spelled COLOR rather than COLOUR. So we always get confused there. Okay, I'm not going to go through this whole thing, but you can go through if you want to. And I'll be interested to see if there is, if anyone has picked up the Easter egg anywhere, which is the reason why this piece of code, even though it did run, has an actual error in it. So I don't know if you can find it. You do have to do a bit of cleaning to find it usually. One term I did have a student actually pick the error out of all this. I'm not sure how they pulled that off. Yeah, but anyway, if you want to, as an exercise, you could go through and transform this into good-looking code, which is actually just reverting the transformation I did from good-looking dice checker to this horrible-looking dice checker, and you can go back again if you want to. So a lot of everything that I saw in the comments, there were nearly too many comments for me to read there, were saying really, really good things. They were saying really useful things for how for the issues that we've got here and how you might want to fix them. Ray's asking if we get extra credits for this. You get extra marks, and there's marks spelt with a C, which is my eternal respect and gratitude for putting effort into learning. Someone said line 19 looks off. Yeah, it looks very off. I don't know if it's wrong. There's an if statement here with no brackets. An if statement with no brackets is actual legal C. It'll work, but it's confusing because sometimes it's hard to know where the if statement starts and finishes. So I don't, in general, write if statements without brackets because they're kind of scary. So this is an if statement where if it's true, it runs this line. If it's not true, it skips over the line and does other things. Technically, the if statement will run the next thing that comes after it, or it will skip the next thing that comes after it. And if the next thing is contained in brackets, then this is seen as a single object to the if statement. So it's a subtlety. This is much easier to read than this. Anyway, I don't want to go into too much detail. We could spend 2 hours just on this one piece of code and talking about it. And I do kind of want to, but I need to move on. Okay. So here are a lot of the specific issues. Oh, we didn't even talk about the header comment. So I don't know if anyone pointed that out. There was too much going on in chat for me to read it all, so I apologize that I didn't get to look at it all. But the header comment never said what the program was supposed to do. So it's really hard to tell whether the program's working correctly if there's no information about what it's actually intended for. So there were no blank lines. Someone definitely said that. Multiple expressions on the same line. Yeah, we even talked about that. Inconsistent indenting and spacing. We didn't even talk about the space between the mathematical operators, but I'm sure that people said, I think I saw that once or twice in there. Variable names don't make any sense. Yeah, we definitely looked at that. Oh, the comments don't mean anything as well. The comments were like, yeah, they're pretty messy. Bracketing wasn't indented correctly. Oh, there's 2 identical code blocks in there for checking both of the dice. They're structured completely differently. I remember this because they're not even spaced and indented differently. They're actually written differently. They're actually running a different algorithm on both of them, which is really confusing and can cause a lot of issues. And the Easter egg, there's something in there that doesn't run correctly. And I even ran it once to check, but there's other things happening in there that aren't running correctly. See if you can find it. Okay, let's talk about what we actually want to do to make sure that our code doesn't reach this situation. And this is an extreme situation. We're not going to see code like this that much from you, but it's the little bits that are on their way to that code, but not all the way, that are things you want to work on. And this is advice that I was given years and years ago. Oh, hello. Oh, she actually looked at the camera once. That's pretty funny. When the example that I was given years and years ago is if I need to clean my room, it is much easier if I clean up my room once a week or once a month or hello or like at little regular intervals. It's much easier to clean my room like that than it is to wait until it gets to the stage that that piece of code is at and then clean it then. Because if I clean it right at the end after everything has gotten really really messy, it's going to take me so much more effort than it is to just do regular little cleaning, or just keep it clean in the way I organize it to begin with. So here are some things that we can do when we're writing code. Sometimes I like to write comments before code, so that way the comments are already there, and not only do they help someone else understand it, they help me remember what code I'm going to write. Also, name your variables before you use them, so don't name your variables A, B, C, and then afterwards go, oh, wait up, I'm supposed to have better names for these, and go back and change them. You've already set yourself up for making mistakes with them if you've named them badly the first time you've created them. So, name them for a purpose, and then use them. Bracketing. Everything inside a bracket goes forward 4 spaces, and the closing bracket and the opening bracket are lined up. It's the line that opens the opening bracket is lined up with the closing bracket. Some people also do a bracketing system where the opening bracket is on the next line, so that way you can really clearly see where the brackets open and close. I'll show you actually. So this is the method we're using in COMP1511. It's still reasonably easy to see where the brackets open and close. Some people do it this way. So they have the statement there, and then the curly bracket, open and close, happens at exactly the same depth in indenting. So this is a way that people can do it so that it's like super, super readable. I'm easy either way. I've worked for years in this method, and I've worked for years in this method. It really depends on the company or institution you're working with. One of the most important things is that no matter what style we're used to, we need to work in the style that the company works in, because consistency is going to be more important than the minute difference between whether we think that one style is better than the other. So I think one of the most important things to learn about is that we get caught up in things, right? So we get caught up in like this PlayStation versus Xbox mindset, where we think one's better than the other, and we think that if one of them's always better than the other, then we should always use one over the other, which is a complete fallacy, because there's some games that are on the Xbox that aren't on the PlayStation, and there's some games that are on the PlayStation that aren't on the Xbox. So you should use whichever one makes sense for what you need to do at that particular time. So while I say in COMP1511 we have a style guide that says we're going to do our bracketing like this, that doesn't mean that the first time you step out of COMP1511 you'll be put into a situation where this is the style and you'll be expected to go to that style. So the way that I like to say it is like, keep flexible and keep an open mind, because you're going to need to be flexible in your work. So you'll need to be able to use whichever style the rest of the group you're working with is using. Okay, so I have specific slides for each of these. I don't know if I've really got time to go through them, so I'm going to go through them pretty quickly. So comments before code is this planning ahead idea. So this, I can say check against the target value. I have one for success, one for tie, one for failure. I didn't even do the tie when we did this example, but it's like something that I said that we could do. I've got all my structure here, and I've got my comments, which means now it's pretty easy for me to write code in here. And if this code gets really big and complex, when I go to this if statement, I've got the comment there saying, okay, this is what this one was for. So I don't need to look at the rest of the structure if I'm doing this else if, because I've already got the comment in here telling me what's happening. And if I want to, I can leave these comments in here afterwards, because they're pretty handy for someone else reading this to be like, okay, that was the success, that was the tie, this is the failure. It makes it easy for me to see what's going on. Oh! Taylor Chan! Bam! Okay, I think you've got it. Line 26. Does line 26 intend to check if the second dice roll is valid, but instead uses A? Let's look at this. If A is less than 1 or A is greater than dice size, this is the value of the second die, scans into B, second die scans into B, and then we check A for invalid values. You got it. You got it. Well done. Oh my god, PC Master Race. That's, yeah, exactly. So there's like, oh yeah, I say PlayStation versus Xbox, and then someone always says PC, and I'm just like, okay, so that's exactly that's exactly the problem. Us holding to one particular form of doing things, and that's what I want to teach you is, and this is an old school gaming thing, right? Yes, Alvin, special prize, give Taylor a chocolate. This is not going to work at all. I don't even know what country Taylor is in at the moment. Yes, extra marks, auto HD. Yeah. Anyway, what was I going to say? Oh yeah, the whole PC Master Race thing. We get into the point where we think that one way is better than other ways, but the only way that's better than the other ways. This is an old school gaming reference. Has anyone ever seen Pure Ownage? It was like a I don't know if it was YouTube, but it was a web series that happened maybe like 15 years ago or something like that. And it was like this person that was just trying to get really good at games, and they go to this master that teaches them, and it was like, you get into this mindset that you think that some games are better than other games, and you should only be good at the games that are better than other games. And it's like, no, to truly own, you must own at all games. And that's the same thing as saying you have to be good with an Xbox, PlayStation, and a PC if you want to really be good at games. And what I'm saying here is you have to be able to write code style that fits with other people, not code style that you think is just superior to others. And that's the way that we want to work, right? The way we want to work is, if we're writing stuff so that people will understand it, we need to think about the context under which they will understand things. Yeah. Terry says give them a Switch. So Taylor, you can. I'm not going to give you a Nintendo Switch. All right. So let me go back to my slides. All right, comments before code. A, it allows us to do our planning more easily. B, it means that we don't need to think about a larger structure. We just think about what's amongst that comment. Naming variables, I probably don't have to go over this so much, but I want to give you some rules for naming variables. So, can you describe exactly what the variable is for in one word or two? If your lab partner or someone else was to read the name, would it make sense to them? And does it distinguish itself against other variables? So, for example, here, A and B are the values of the first and second die. So if I say something like die value and die value, these both are a correct variable name for the purpose of the variable, but they're a very, very bad variable name because they don't distinguish between themselves. So you see how we want both of those things. I'm just going to Control Z this because I'm not going to go through and do the whole replacement thing at the moment. So variable names, we want them to be on their own, stand out from each other. Indentation, and I think I showed you this a moment ago. Everything inside the main will always be indented 4 spaces, so we know where our main function is and what's happening. And if I open brackets, everything inside the open brackets gets 4 spaces in. If I open another set of brackets, we'll go 4 spaces further, right? And every time we close a bracket, it lines up in terms of the indentation with the start of the line that opened the bracket. So this is the line that opened the brackets. It started 4 spaces in. The closed bracket will also be 4 spaces in. And that way it's really easy to see that this and this contain everything that's inside. This is something that I've been doing the whole time. Depending on what code editor you're using, some of them do this automatically. So some of them just automatically indent your code based on where they see your brackets. But it's just a good idea to get a handle on doing this. That's another reason why we actually use an editor that doesn't do this, because as much as you would get a really good result out of your editor doing it for you, I prefer if people do it themselves, so that you just get it into your head that we're going to do this, rather than just saying, I never need to worry about indentation because the editor always does it for me. And then when you get to a point where you have to think about it, then it's much more difficult. Okay, one expression per line. Some questions here. Catherine's asking you about where exactly to put comments. Sorry. The comments slide. Where are we there? The comments refer to the statement above it. You tend to write comments for what's happening next. Is that okay? Yeah, you can do that if you want to. The trick with if statements is I tend to put the comments inside the curly brackets. So I say that inside this curly brackets, I will only reach this comment if this was a success. So that's why I often put comments inside the curly brackets, but some people will put a comment before the question. Having said that, the implication of putting the comment before the question is you're talking about this entire block. So it's fiddly once there's lots of bracketing going on like this. I would tend to comment if statements like this. Sometimes I will put a comment even on the same line as the if here on the brackets, but that depends on how long that's getting. If it gets too long to the point where this question is so long that the comment's over here, then it wouldn't get read. Yeah. Max is asking, can I use simple variable names like N1 and N2 for number 1 and number 2 if I explain what they mean in the comments? I would say that only maybe is that a good thing. Because if I have N1 and N2 and I explain them when I declare them, they're still not explained later on in the code. What I want is for 1,000 lines later in my code, someone sees N1 and they know what it means. So if it was initial value 1 or something, or dice value 1, then you don't need to go back to that comment to find out what it is. You read the variable name itself somewhere else deep in our code somewhere, and you don't have to go back to the comment to see what it is. So I would be I'd be a bit leery about using the N1 and N2 as variable numbers unless there was literally no, like they were dummy numbers and they had no purpose other than to be a number. Ray is saying there was a very good argument with using tabs over 4 spaces, which is accessibility. Some people with vision issues have code really big, which screws up with spaces. Yeah, I mean, when we're using something like gedit, I would actually use the tab key to indent things. In gedit, the tab key actually puts 4 spaces into the text. Different programs will use tabs versus spaces. Whether the tab is actually a character that appears, like an invisible character that takes up a lot of space, or whether when you press the tab it puts spaces in there. It sort of goes back and forth depending on the editors themselves. Okay, I'm going to keep going because I'm way over time at the moment, nearly to the point where we're not even going to look at functions today, and I'll have to push that later. Okay, so we've talked about naming variables, we've talked about indentation. 1 expression per line. I think I talked about this while we were fixing things. If I do it like this, it's pretty easy for me if I read normally, which is scanning downwards line by line. I'm going to miss some things that are happening. Whereas if I do it like this, line by line, I know that each line has exactly one purpose. And if each line has exactly one purpose, I only need to read the start of each line and I can understand most of what's going on. Here, without this, I need to scan across, and it's like reading a book where I want to read every single word, I have to scan all the way across. This makes it much harder for me to understand the structure of something by skimming downwards. So lining it up like this is much harder to read than lining it up like this. Spacing. So this wonderful mess here. So we didn't really look at this too much in the previous example, but this mess here is going to be super messy. Whereas this is a little bit easier to read. It's just like more comfortable for your brain, you know. Like when all the symbols are smushed together like this, it's harder for me to see what is the variable name and what is the operator. Even though I know them well, it's still hard for me to see. Whereas this is like, okay, everything's got a space between it. Just makes it easier for me to see what's going on. Okay. If we want to to look at exactly how we're doing style in 1511, we have a style guide. And as I was saying before, this is not the ultimate style guide. There's no such thing as a correct style guide. We have had multiple polite conversations, raging arguments about what we think the style guide should be in 1511, and we go back and forth about this, and that's fine, because everyone's going to think certain styles are better than other styles and things, and so it ends up just being this is the style that we're going to use here and now, but it's only one potential style, and then other places can have different styles. Your assignments and the exam will have some stuff on style. So we'll be expecting, your assignments have a specific amount of marks set aside for code style. The exam will have some questions on it as well. Oh, hey Shrey. Charles is asking about methods to efficiently calculate inverse square roots. We're not going to do that right now, Charles. You can talk to your tutor about it later, but we're not going to do it in the lecture because I don't think it's like course content for right now. All right. Yeah, and people were talking about what Catherine was saying there about preference for where comments are. Since comments are for humans, then context can also dictate where they are. All right, I'm a little bit over time, but let's go on break. I would put my face over Ryan Gosling's, but I think that people would much prefer to see his face than mine. Oh, Matthew Dang is asking if there are any style checks for the assignment. We don't necessarily have auto tests for it, but what we do have is, I'm going to clear this thing called 1511 style. And I think this has been in most of the labs to say you can check your style with 1511 style. This is going to be, this is potentially going to be very, very bad, but we'll see. What was it called? Code style bad. You can type in this command if you're on our systems, 1511 style code style bad.c. This is not the be all and end all of style because this is just a script. And all it does is going to look through and see the things that it thinks should be changed, but it's not going to know whether your variable names were correct or not. So, indentation red green, it will highlight which lines have been indented correctly or not. So this is the start, and it says, okay, there's an error. You didn't put your ZID in the header, so you didn't actually say this is my code. But it can't tell that this header comment doesn't have any useful information in it. So so it's still a robot. It can't tell you things about that a human would need to know. But it says the indenting is correct here, and then it gets bad here, which is good because this is the bit that we started fixing. But it also has some warnings. There's a weird white space here. Variable naming might not be that great. So it can tell if you have single letter variable names, and it'll try to warn you that that might be an issue. Line length, the line went over 80 characters, which is, it's trying to let you know that's going to be hard to read. White space issues, more white space issues. Yeah. And it says, okay, here are some things that you might be able to do to improve the style of your code. So it's worth running this on your code. Oh, my face was over half of that. Sorry. I'll move my face back over there, but I'm about to go back to the slides and have to move my face again. All right. So this is one of the funniest memes. There's a whole series of programmer Ryan Gosling memes that I think are hilarious. So I had to throw one in here. So anyway, code style is about reducing errors for ourselves. So making it so that we make less mistakes. We make it easier for our code to test, make it easier for us to see what's going on. Also makes it easier to change. In general, it speeds up development, and I just threw this one in here for the fun of it. Yes, it makes your coworkers hate you less because it takes them less effort to read your code. Okay, we're going to take a quick break, and we'll come back, and then we'll fly through the rest of the lecture, and I'll try to get as much done as I can in the half hour or so that we have remaining in the lecture. All right, I'll be back. All right, I'm back. There was a little bit of chat there that I was looking at when I got back from break. The 80 character limit is not about the size of your screen. Initially, years and years and years ago, it was because terminals, so the actual monitor terminal that they used to use, the standard monitor for programming. This is like 1980s level stuff, right? Where actually the characters getting printed to the screen weren't being re-rendered by a graphics card or anything. They were literally, the characters were just going to be sent to the screen from a bank of possible sets of pixels that could go to the screen. That used to have an 80 character limit, which is exactly how many letters could be shown on the screen. Nowadays, we use that still because of the human reason, not because of the monitor reason. And the reason is how much your eyes move, basically. In fact, with a font this big, my line limit should be shorter than 80. And it's all about scanning downwards. And the longer this line is here, for example, the more likely I am to miss these variable types that are over here, because my eyes are only going to see about this much of this line when I'm scanning downwards. So the 80 character limit is not there because for any technical reason. It's just a number. Like if I wanted to, I could say a different number. So I could say that this should be a 65 character limit, or I could say this should be a 90 character limit, but we use 80 because it's a recognizable standard that a lot of other people are using, and it's not about the number of characters, it's about how much a human eyes are going to look at. So we like to read code by moving our eyes up and down, and not that much side to side. And the more we have to move them side to side, the more likelihood it is going to be that we're going to lose something. So that's why we have a line limit. So yeah, I mean, people are talking about wanting to use the full width of their monitor. Like, the whole idea of the 16:9 monitor is just like, it's a bit of a mess. It's there because the film industry likes 16:9, but if we wanted to program well, we'd all be flipping these on their side and having a taller rather than wider monitor. It's much easier to work with code on something tall. I used to do that a lot. That was back when I was working somewhere that would buy me nice monitors. I mean, CSC's got a nice monitor for me. It's in my office, though it's not here. But monitors you can actually rotate because it's much easier to code on something like that, or even on a tablet that's in portrait mode. But yeah, that's the 80 character limit there that we're talking about. It's really got nothing to do with the physical capabilities of what your monitor can do, because it doesn't really matter how wide your monitor is, you still can't look at all of it in one go. Anyway, people are talking about Order 3 and Spiral and stuff like that. Yeah, so there's a lot of stuff going on with Order 3 and Spiral. I'm gonna let that simmer, though. I'm not gonna talk about that. Maybe I'll talk about it on Thursday a little bit, but who knows? Okay, so oh yeah, Shrey's talking about having monitor arms and stuff. Yeah, that's a lot of fun. Okay, so I wanted to talk about the weekly tests because they're going to start this week, potentially Thursday evening or Friday. I don't want to release them or make them due during a lecture, though, because I think that's a bit distracting. Especially don't want people to have to work on it during a lecture. So if the due date was during the lecture and people are kind of cramp for that finish. So I'm definitely not going to have the due date in the middle of the lecture, but we'll see exactly how that pans out. The way the weekly tests work is they're kind of a mini exam that you run for yourself. They're in the true spirit of what an exam should be. So an exam should be your chance to find out how much you know. In a university, an exam is also our chance to find out how much you know, so that we can say, let's put a rubber stamp on this person saying they know everything they need to know to pass COMP1511 and go off into the world as a person who's been introduced to programming, which is the course. This is for you to get a chance to see how you're going. So when you first open the questions for the weekly test, we've got a little, I think it's a JavaScript thing or a Python thing that just gives you a 1 hour timer. If you are completely uninterrupted for that hour, you can work with that timer and you can say, all right, I'm going to do the weekly tests exactly within this timer. Obviously, because we're all working at home and stuff now, and you can't just like sit in the corner of a lab and really kind of have less distractions. You turn off your phone and stuff like that. It's hard to actually get the proper hour, so don't worry too much about the timer. But the rules are in the test itself where they say, okay, don't look anything up. We do have a cheat sheet that has some reference information about C and stuff like that, but otherwise try to do it without anything like that. So you have 1 hour, and at the end of the hour you can stop and you can say, okay, how far did I get? Was I able to complete all 3 questions? Was I only able to complete 1 question or 2 questions? You have a decent idea how you're going. If you complete the first question, then it means you've got like the core basics of what's going on. If you complete the second question, you're doing reasonably well. If you can complete all 3 questions in the hour, then you know that you're right on top of the content. So what this does is it gives you an idea about what you do and don't need to study for. And also it's a really good practice for coding with time pressure without any resources around you, which is what's going to happen in pretty much any technical job interview, but also in exams and stuff like that. So in a sense, what it is us giving you a chance to practice coding under pressure so that when we give you the exam at the end of the term, I mean, you got 24 hours for the exam, so it's a little bit more open even. But at least this means that you won't have to deal with the time pressure the very first time in the exam where it counts for so much. You can do it in this where it's not super important for you to get everything right and stuff like that, but just practice being under pressure. So the best way to be able to handle huge amounts of pressure is to practice handling smaller amounts of pressure over and over again, so that when the huge pressure hits, it's not as big a deal. Like you've already got a way of dealing with a bit of pressure. So the 1 hour is for you to figure out where you're up to. And then if you want to, after you finish that hour, you can go back and you can look up resources. You can spend the rest of the week finishing the questions if you really want to. Sometimes that's good. I mean, I know a lot of people who are not happy until they figured out exactly why things were and weren't working in the first hour, and they go back and they make sure things are working, and then they resubmit. We don't mind if you resubmit the weekly test, so you don't have to say the first hour is what you submit. The first hour is for you. So that's for you to say whether or not you're doing well in the course. So one of the tricks is don't look anything up before you start it, because if you look stuff up before you start it and while you're doing it, then you're not going to get a good appraisal of where you're sitting in the course. You're just going to think that you're doing really well when you might not be. So the best way to do it is that first hour, hit it blind and just go for it. And if things are missing, then at least you know what you need to study. Okay, they'll be coming out in a couple of days. Eric's saying, yeah, you're asking if we submit it, we still won't know if it's right until it's due. Yeah, that's true. I think that you will be able to use stuff like the auto tests to get a reasonable idea of how you're going. And you'll also have, in your heart of hearts, knowing how you did. You know, I wrote code and I don't know why it works, and then you know that you didn't get it. Or at least you know that you may be passing the test, but you're not sure why, and you know you want to go back over it. You'll sort of have a decent idea about what you do and don't understand. When we throw the question at you, and you're like, you look at it and go, yeah, I can solve that. Or you look at it and you go, I'm not sure about that. That's the thing we're looking for. That's the feedback, you can tell. Mingji Lee says, how many times can we do this? Since it's self-invigilated, you can do this as many times as you want during the week. I think that doing the full self-invigilated thing after the first hour is a bit more pressure than you need to. I would only do the whole self-invigilated exam thing for the first hour. And then after that, I would treat it the same way I treat like the lab exercises, where I'd be like, okay, I'm going to look up some information on this and I'm going to learn, you know? So you test yourself and then you learn about things. So we still want to be learning. Okay, I'm going to move on. Okay, we're going to do code reviews. I just said okay like 8 times in the last minute. I get like this when I'm trying to go fast, and I think going fast is not as good as covering content well. So I'm just gonna cover content well instead. A code review is having other people look over your code. This is something that we do in industry a lot, where we will actually get, maybe within a team of coders, we'd have like, say, 4 or 5 of us in a room together and a projector and someone's code up on the projector. And then we would talk about their code, and we would have one person saying, okay, here's my code for this thing. I was attempting to implement this particular algorithm that I got from this paper. You might know this already, but this is how it works, and this is the code I wrote for it. And then the rest of the people in the room can have a look at it, and they say, hey, what'd you do there? I don't understand what that bit of code is doing there. And we can talk about, is this code not super readable? Maybe I need to change it so it's more understandable. Or it's like, that's a really interesting way of going about that, because I would usually do it this way. And then you would discuss different ways of solving the same problem with different types of code. And then within the group, you could be like, oh, that's interesting. Why is that better than this? Or is this better in certain circumstances, or is this other technique better in other circumstances? And one of the tricks about this is these code reviews are one of the best ways that we as programmers get better at coding. So one of the worst things that we could ever do as a programmer is only ever see our own code. So we do actually want to look at other people's code as much as we can. We can get caught up, and this is something that I acknowledge is definitely a risk with the way we have set up 1511 with auto tests. One of the risks we can get is that people start programming just for tests. They program just to pass the auto tests, but not for all the other things that are important for writing computer programs, which is like, can other humans use it and can other humans understand it? So having this situation where we would go through and sort of proofread our code with other people and do it live with other people gives us the ability to discuss these things. So a couple of things that we would do as the person who wrote the code or as the person who's reviewing the code is when we put our code up, we want to see whether people can understand it easily, and we also want to see whether our way of solving the problem matches the way other people would solve the problem, or is different from the way other people solve problems in interesting ways. Yeah, I think I've just talked about this already in the first slide. Yeah, we're going to see the way other people solve problems, and we're also going to get to see the ways that other people write code. One of the easiest ways, I think, to pick up really good code style is to code review a lot of other people's code, because everyone's going to be better at some parts of it than others. And if you cherry pick like the best way that lots of different people write code and pull it together, then you could have like this really, really nice elaborate, really nice elegant style that works. Because I think you could, if you wanted to, just write code exactly the way I do, and that's okay, because I'm being really careful with the code that I'm writing for the course. But there are other ways to make code look really nice that aren't just exactly the same as what I do. So there's different ways to review code. Pair programming is a way that's pretty good to review code. So it's harder to do in an online environment, but you may have done this a little bit in your labs, and I suggest trying to do this more in your labs. It depends on your bandwidth. But what's really great to do in the breakout rooms in the labs, if you're in the breakout room with a small number of people, is one person is writing the code and they share their screen. And then 1 or 2 other people, you don't really want too many people in this pair programming style, are watching that person while they code. And then while one person's coding and one person's watching, you get one person thinking at a high level for the problem solving kind of stuff, and the other person thinking at the low level of translating things into C. And between the two of you, it's really easy to sort of catch each other's mistakes, go back and forth, talk about it, and things. So this is something, it's the funniest name. So it must have been invented in the 90s. It was called extreme programming. It's like people trying to sound cool. So extreme programming was literally 2 people with 1 computer. And it was like this. One person was thinking about the overall idea while the other person was thinking of the nitty-gritty of what they're doing. This actually reminds me of, like, I technically invented extreme programming back in the early 90s. I like to claim this because it's not true, but I claim it anyway. Where we used to play Command and Conquer between two houses. And this was back in the day where, in order to play games over a network, you had to literally call the phone number of the other person and have your modem talk to their modem directly. And then when the modem's hooked up, you could then run your game and have your game run between you. So it was really funny because you'd be midway through the game, and then your dad picks up the phone somewhere else in the house, and then that's it. The connection's ruined, and it's all over. So, funny times. But we used to do this thing where I had myself and a friend versus a pair of brothers, and we'd always have one person on the keyboard and mouse, and one person just sitting over their shoulder looking at them. And so the person sitting over the shoulder was like, okay, go back to base and build this. All right, we got to think about our economy. We need to harvest crystals over here and stuff. And the other person is like the micro, right? So it's macro and micro. This is any of you gamers that play real-time strategy games. We talk about micro being your ability to move individual little pieces, and your macro being your ability to plan your structure of things. It's exactly the same with programming, and pair programming works really well with that. So yeah, we used to do that, and it's super effective. A lot of the time, depending on the kind of code you're writing, this is actually more effective than having two people work separately on their own code, because it just generates less mistakes than otherwise. So you get this kind of thing where you can review it as you're writing it. Mason is asking if code reviews are something organized during tutorials. Yes. We will actually be trying to do a class-wide code review at the start of every tutorial from here to the end of the term. We'll see how we go. Some of the tutorials will be too busy for it, others won't be. We'll see how we go. But definitely next week's tutorial, not this week, because some of you already had your tutorial this week. But next week we're going to start with code reviews. The other thing that we can do is the more formal code review, which is where we take a section of code that's at least partially finished, or sometimes we will present something that doesn't work, and we'll say, hey, I need eyes on this. I need other people to have a look at this and see whether this actually works or not. So, pair programming, I should have gone to this slide before I started talking about that. One person on the keyboard, one person looking over their shoulder. When we're in this online environment, it won't be like that. It'll be one person on the keyboard sharing their screen, and then a couple of people maybe looking at what's happening on the screen and talking about it. So active discussion as we're going, and the code is being reviewed as it happens. So it's cool because one of the things you'll get with that is the person looking over the shoulder is going to say something like, hey, what's happening there? I don't understand what that is. And that's really good because that'll give you an indication as you're writing the code that the style is not readable, you know? So you get that kind of feedback as you're going. So one thing to remember, and this is one of the funniest things about code reviews sometimes, is it is not a witch hunt. We are not trying to find all of the errors in someone else's code and make them feel horrible for having errors in their code. What we're trying to do is help people with their code. So, and that's help, not help. You know, people know that. Hang on, let me just type it in here. Not helping. Yeah. So when we're trying to oh yeah, Eric's asking if we're covering functions in this lecture. I do want to cover functions in this lecture, but we'll see how we go. We might push it to tomorrow. Not tomorrow, Thursday. Depending, because we've only got like 15, 20 minutes left, and I still want to talk a little bit about code reviews. So we're not necessarily going to pick at people's mistakes, but we're trying to help people. One of the best things we can do when we're reviewing someone else's code, and it's a hard thing to do because it's always a hard thing to say to someone, is to say, I don't understand what's going on, because we always like try to pretend that we understand everything. It's just like a really common thing for humans. Me as a lecturer, I'm always pretending I understand what's going on when I'm teaching you, but you know, it's the truth of it. We're all just kind of floating along in this kind of like hoping to look like we understand stuff. So one of the difficult things is to be really honest and just say, I don't get what's going on with that bit of code. And it's really, really nice because what it does is it helps people figure out whether that bit of code is confusing and how it might be confusing. We also like to talk about what are the different ways that we could do the same thing. So this is really great when you're code reviewing something from say last week's tutorial or lab, which means most everyone has done it, and everyone's going to have a slightly different way of doing it. So that always leads to really interesting discussion where we can say, oh, I did it this way. Oh, really? I did it this way. And then you can think about what's the difference between those two ways of doing it. Is there something about one that's more useful in some ways, something about the other that's more useful? Is it just layout? And maybe layout is going to make it look different? Or is it a genuine solution difference? And this is where we get into things where we might say, well, this one's better in these situations, this one's better in other situations. And also, if someone has some issues and they say, okay, I wasn't sure how this worked. In later code reviews, we're actually going to ask for volunteers to be the reviewee. And that can actually work really nicely, is you can say, here's my lab code from last week. I didn't pass all the auto tests, and I'd love to get a hand on what it was that did or didn't work here. And you can put your code up for a review, and we can talk about it, and we can talk about how we can help with that. Yeah. Okay. What not to do in a code review? I think I already covered this in a bit. You did this wrong. Your code is bad. Here are all the mistakes in this code, right? So we're trying to do this without judgment because we're trying to help ourselves and other people learn. So it's kind of important that we don't necessarily just throw someone under the bus because they've gone out of their way. And it's actually kind of daunting a bit to stand in front of a group of people and say, okay, here's my work. This took me hours to do, right? And it's really hard to go up with something that took you hours to do and say, can you pick at it, please? You go to a group of people and say, can you pick at my stuff that I put blood, sweat, and tears into? It's really like a daunting thing to do. So when someone does that, we want to kind of applaud them for doing that rather than saying, oh, let's tear apart everything they can do. Oh, that's what I'm saying there. It's hard to do this, so we just want to be understanding of each other. Also, this is something it's really interesting, and I've said this already, there's more than one way to solve any problem. So if we have different ways of solving something, yes, we can both be right, and we'll be right in different ways. The more important thing in code reviews, especially as a student, is your aim as a student is to learn as much as you can. So try to take that from the code reviews. What we're going to do is we're going to see other people's code, and in seeing other people's code, we're going to get pointers on how to structure our own code. So either we want to emulate what the other person's doing because we like it, or we say, oh, that's interesting, I'm going to take some parts of it and not the other parts. Charles wants to put his order 3 up, and there's pitchforks there. David Wang wants Gordon Ramsay feedback. You want someone to grab you by the collar and yell in your face about things that aren't working. Having said that, one of the funniest things about Gordon Ramsay is have a look at the difference between him when he's working with professional chefs versus when he's working with the kids' cooking competitions. It's really amazing, and it's one of the reasons why I have more respect for him than I used to, is that he knows when and who to apply pressure to, which is the mark of an actual teacher. So when I have a student who is like really, really pushing and they want to be the best, the best there ever was, then like that little quote, I will tend to push them really hard because they'll be like, I want to push, so I'll push hard. But if I have someone who's like, just starting to learn and starting to get into the wonder of what it is to program, then I'm just going to be super encouraging, and I'm not really going to care whether they're making mistakes because it's about them getting a joy of it, and the joy will lead to competence later on. So the way that Gordon Ramsay talks to the kids is super, super encouraging. It's really inspiring and all this kind of stuff, because who cares if kids make mistakes? They shouldn't be punished for at this point. We should be seeking out mistakes because that's how we learn. But a professional that's serving food to people who is paying for it needs to be needs to have a conversation about their mistakes so that they can get better, and they don't need to be inspired because they've already decided that it's their profession. So it's a little bit different thing. Yeah. Okay. So everyone in chat is now just talking about Gordon Ramsay. Okay. All right. Let's move on. Okay. So next week's tutorial we'll have a demo code review. So a lot of what I'm talking about there will come out next week in the tutorial itself. You can also get people to review your stuff during the lab. So there's a lot of time in the lab. There's 2 hours in the lab, and I would suggest that every lab that you're there, try to at least talk to one of your tutors at least once. So that way you can just sort of get some one-on-one feedback on how you're going, and also try to show your code at least once to some other students and see what they think about it. And this way you can be constantly doing this review thing and collaborating on stuff. Yes, we're not going to do any swearing in the chat. I know we brought up Gordon Ramsay and that's his standard method of communication, but Shrey is having to moderate a whole bunch of messages now, so please don't swear in the chat. We're gonna keep it a little bit above board. Also, it's important because when I do decide to swear in the lectures, that's when I'm going for impact. So we're not going to casually do it. Okay. Alright, so enough Gordon Ramsay-like speech in the chat. Okay, we're going to talk about functions. I'm going to squeeze this in at the end. Don't worry, this is not the only time I'm talking about functions. But I'm going to introduce functions. But I want to introduce functions in such a way that you have already seen them. So int main is a function. Printf and scanf are also functions. So I want to show you what a function is. A function is a separate piece of code that has a name in the same way that a variable has a name, but a variable is a separate piece of memory that has a name. So it's memory that stores a value. A function has a name, but it's not just memory. I mean, it is stored in memory because everything is stored in memory, but a function is a series of instructions. So it's actually a series of lines of code that exist somewhere else in our program. And what we can do is we can give information to a function. The function will run some stuff on that information, and it might give us some information back. So whenever we use the function in our code, we call it calling a function. So we call a function, we call it by name, and it runs that code. So it works a little bit like this. So I want to do this with a diagram first before we delve into actually how the code works. But our main is what we've been doing. So all of our programs so far, and all of our programs continuing from here, will have a main. And that is a function that runs line by line. And it says, okay, I'm going to do all this stuff. So this is no news to you, right? All the programs we've been writing have gone line by line. And they might switch some lines on and off with if statements. While loops might mean they may repeat the same lines. But the general movement of it through the code is we do this line, then this line, then this line. We can call functions. And calling a function says, I was going line by line through my code. Now I stop my code. I jump across to another piece of code somewhere else, which is the function, and I run everything in the function until the function says you're going to return to the main. And return to the main means go back to where you were before. Maybe you go back with new information. Maybe you go back after a separate task has been done, and we go back to wherever we were in the main. We return to where we were in the main, and we keep going. I keep using the word return. Return is a keyword, and return says that a function is finishing, and you're going back to where you were before. So we've seen the return keyword. I explained it in a simplistic way to start off with because we didn't know about functions. So I said return was just going to end our program. Now we add a little bit of subtlety to that to say that return is going to end a particular function. When our entire program was in the main function, return was going to end the whole program, but return is actually used to end a function and return to the main. So this is the kind of format we have now. We're not just in one block of code that goes line by line. We can jump out, run another piece of code. It's still going to go line by line, but when this finishes, it's going to return here and then keep going from where it was up to before. So there was a question there Mason is asking, I say return is about ending the function, but how does it work when we put a math equation after the return? So return might return a value. I'm going to talk about this in a second. So return of a function might say the function is going to give back some information. And so that equation there, the line that return is on might end the function, but it still might run something in that line. Jasmine's asking an interesting question. I am going to answer this in these next few slides. How come we need to put an int before the main, but not before functions like printf and scanf? How do these rules apply to other functions? So let's pull apart a function, and this should answer your question. So this is how we write a function if we're going to create a function in our code. So we've seen int main void. I'm going to now show you int add. So this is a new function. This is a function I've created. It is a completely trivial function because there would never be a need for us to write this. But I'm showing you the structure of a function by doing this. So a function has an output. It has a type. And this one is an int. So these types will be the same as our types of variables. This is the information that the function will give back when it returns. Then I have a name for the function. This name is the same kind of thing as we're naming variables. We want to give it a human readable name so it's understandable. And then it might have 0 or more inputs. My main, the way that we've been using it, has 0 inputs. It has a void in there, and void is just a keyword for nothing. Sometimes we need to explicitly state nothing, but we can actually write a function that just has nothing in these brackets and it'll be fine. Here I'm saying int a, comma, int b. What I'm saying is for this function to work, it needs to be given 2 integer values. The first one we'll call a, and the second we'll call b. These 2 variables are created when the function runs. So these are new variables that are created when the function runs, and they're given values by other parts of the program. So note the difference here between a value and a variable. A variable has memory, a value is just a number that gets passed around. So these get created when the function starts, and then the function runs this one line. And so when the function gets called by something else that gives these values, it will just give back the addition of the 2. So a plus b results in an integer, and we can return that integer. And we can only return something that's the right type for the type of the function here. So I'm returning an integer to this a plus b, which means wherever this function was called in my code, it will give back that. So I've spoken a little about this return. Return will give the output of the function back to whatever called it. So when we're starting out with our functions, we're just going to be calling functions from the main. When we get deeper into it, we're going to call functions from other functions and stuff. So we're going to have this chain of information that gets passed around. Return will always stop the function as well. So any point that we're going to return, we will close down the function and then we'll give our information back. That is if there is information to give back. Oh cool, Shrey's answering those questions there, which is great. Yep. Okay. So if I have that function here, this add function, how would I call it in my code? And we've also seen this before. We've seen a very simple version of this with printf and scanf. So printf and scanf were functions that didn't give back any information. Whereas if we have a function that gives back information, we would call it by name in the same way that we call printf and scanf. We say the name of the function, and then we have an open and closed brackets, and something in those open and closed brackets is information we give to the function. So we give this function the numbers first number and second number. Note that I'm not giving the variables first number and second number here. What I'm actually just doing is reading values out of first number and second number, and then those values are going in here to this, which creates new variables for itself that exist inside its curly brackets, so they'll exist only this long and then disappear, called a and b. So when I call a function, I give it some information and I expect it's going to do some processing, and then it returns. When it returns, what it basically does is it takes this thing that it was called and it transforms itself into the answer. So add 4 and 6 here is going to run, and when it returns, it's going to transform itself here into the result which is the return value, which is 10. So it's like I put the number 10 here, and then total equals 10 says that the result of this function running, which happens to be an integer because this function is an integer function, will then get stored in this variable. So that's the basics of how a function will run. There are questions here. Oh, Tiara's asking a question. Can we call functions from other documents? So from other code files? We can if we have included them. We're going to go into that later. I'm not going to talk about that till next week, actually. But yeah, we are going to be able to call functions from other places. This is actually just an intro to functions, and then we're going to go deeper into it as we go along. So the other thing is, when we are compiling our code, our compiler needs to know what our function is. So we can't call a function without knowing what it is in advance. So here's a simple example of a variable. Here's a number variable, and then we're doing some operations here with the number plus other number. And it's like, what's other number? Other number is declared here. Int other number equals 5. However, at that point in time in our code, us going top to bottom, we don't know what other number is, because other number is declared after this line. Functions are going to work in a similar way, where if we haven't declared what a function is before that part of code, our compiler is going to read line by line, similarly, but not exactly the same, subtly different from how our program runs line by line. We need to have said what the function is before we start to use it. So what we do is this interesting way of doing things here, where we can have a function here called add. I haven't actually defined exactly what this function does, but what I've done is a declaration of the function that says this function has this kind of input, it has this kinds of outputs, and this is its name. So I can say there exists this function, and because I've put this before the main, then in the main, anywhere I want to, I can use this function. So I can say that you know that there's a function called add. Add takes in 2 integers and is going to give back 1 integer, and you can use it in here. If you need to know for sure what this thing does, it'll be somewhere in this file. So here we've defined it below. As the question there from Tiara was saying, you can put these in other files so long as you've included them, but we're not going to talk about that yet. I'll talk about that later. But the hash include was how we were using things with standard input output and things. We're going to go into that in more detail. Don't worry about splitting things up into multiple files until much later in the course. Mason is asking if we should have the main function as the last thing in the code. Sort of. It just needs to be after these declarations. What I usually try to do is I keep my main function as high as I can in the code. So I define other functions below it. So it's kind of like the main function is what you read first, and if you need more information about what these functions do, you go downwards to find it, rather than putting these functions above the main and then having the kind of focal point of the program get pushed further and further down in the file. I usually like the main to be visible pretty close to the first page of the file, and then the functions to get pushed away, because when we use the functions, we may not even need to know what the code inside them is, because sometimes we'll have information about the functions here and here, and so we can just use them, or they have a reasonable enough name that I don't need to know what's going on inside, because the function tells me in its name what it does. Terry's asking about the way that variables work in the functions. Yeah, so the variables don't get given to the function itself. Only the values that were being stored in the variables get given to the function. The function makes its own variables. So this function with its curly brackets is completely separate from this function and its curly brackets. It creates its own variables to use. Sorry. Oh, I can tell I've hit that 2-hour mark because my voice is running out. Okay. There's another thing that we can do called a void function. A void function says, I do not give you back anything. So I'm a function that does some work, but when I finish, I don't return. Well, I mean, I do return to where I was in the code, but I don't return any information. So sometimes we have functions that just do something, but we don't need them to give us any information back. So for example, I could have a void function for add, which never gives me back the total, but instead it just prints the total out. So heaps of the time when we're doing printing out of information, we'll do that with void functions. For example, printf is a void function. At least I think it's a void function. It might actually give us some output at some point, but we treat it like it's a void function. So the void function is something you don't get anything back from. It has no return value, but it still might do some work for you. Um, I use void functions a lot for just send something to the screen. So it's still having a side effect, and it has output in that there's output to the human, but there's no program output. The rest of the program doesn't get any information back from this function. Okay, I made it, and I'm only 3 minutes over time. I will do an example tomorrow. I keep saying tomorrow. On Thursday, that ties together functions with the next thing that I'm going to talk about. I'm going to talk about using memory in a different way, and I'm going to tie that all together in a program. So I won't have a code demo of the functions, although I do have a code demo of the functions in the lecture section. But yeah, so what are we talking about today? So the majority of today's lecture is what I really wanted to talk about, because I think this is something that is going to be important to you for the length of your programming career, however long that is. Whether it's only COMP1511 and you're going to go back to doing other forms of engineering, I know there's plenty of people who aren't doing computing stuff, or whether you decide I'm going to do computing for my whole life, code style is going to be important that whole time. So that's what I wanted to spend most time on, and thinking about readability of your code to humans is as important as the ability for it to work on the computer. And I think that's something that we forget a lot. Code reviews are going to help us do this. Not only are they going to help us with readability, they're also going to help us think about different ways to solve problems. And as much as we can in the lab time, when we're getting together in groups, see if you can do this as much as we can. Have one person in each group showing their code, because what we want is for a lot of people to see each other's code, and for that to hopefully spark discussions about how solutions were made, or how different people are laying out code and learning from each other. It's quite important. And then we started to look at functions. We are going to continue looking at functions later on this week, and we're going to put functions into a code example with some other stuff that I'm going to talk about using memory. Let's have a look if there's any questions here. Oh, Shrey's helping me out. The printf is an int function, and it can return the number of characters that's printed. We don't often use that. And everybody's having a go for going a little bit over time. Yes, I have gone a little bit over time. Okay, so let's wrap up the official lecture here, because I know some people have some tutorials to go to and things like that. So I'm going to wrap up here. I'll take a quick break to have a drink of water and refresh my throat so that I can talk a bit more, and then we'll come back for individual questions and stuff like that if anyone wants to stick around for them. Okay, thank you all. That will be the end of official proceedings for today. Alright, I'm back. Something quite funny is that I thought that I wasn't going to get through functions. It's like I didn't trust Past Mark, because Past Mark wrote these slides, fit them carefully to 2 hours, delivered it previously to a previous class, and then didn't write down any notes that it was overtime and needed to be changed. And I didn't trust Past Mark that this lecture does fit in roughly a 2-hour period. It's always funny like that. Okay, let's look at questions. So I'm just going to go from, I won't scroll back for the moment, but I'll just go from after I finish there. Anyone has any questions, feel free to put the questions in chat and we'll go through them for the moment. Shrey was suggesting for Masony to ask on stream, but if you do want to ask your question now, I can at least stick around for a little bit. Okay, so Michael's got a question there. When it comes to comments, should you try to explain the logic behind your code or just the function? As in, why you have the logical operators that you do or just what they do? Generally, when I put comments in, they'll be to explain a bit of code that's hard to read. So sometimes I'll have like these headings for like a paragraph of code saying, this code does this. I won't necessarily say, I'm using this for this specific reason. So I'm using this test because it's better than this other test or something like that. I might say this test is checking for such and such, but I won't necessarily go into like this kind of justification level of detail. It's more of a, sometimes it's a TLDR. So TLDR, you probably know this acronym, is too long, didn't read. So it allows someone reading my code to not read sections of it and still get what they need out of it. So that's one way that I'll write comments. Another way that I'll write comments is to help someone follow the structure. So one of the things that I'll do, where is it? Here. Actually, no, I'm not going to go back into that piece of code. Here is sometimes if I'm checking something, an if, and then an else, sometimes in the else, I will actually put code in a comment in the else saying what that actually is. So for example, if this was dice checking, this would be if greater than target value. The tie is if equal to target value, and I'll have an else, and then in a comment here I'll say less than target value, so that sort of explains that as well. So I'll go back and forth on that kind of thing. Yeah. Weiwei's asking, if we want to add a comment to the function, where can we put it? The function above the main or the function below the main? Usually I will explain where the majority of the code is for the function. So I will rarely, let's go back to functions. When I'm splitting up a function by declaring it and defining it elsewhere like so, I will usually not put a comment on this part, but I'll put a comment here because I figure if someone's looking for an explanation, they're going to look at the larger section of code. So here is where I'll put the comment saying this function called add takes in 2 integers and returns an integer that is the total of adding these 2 integers together. That's the kind of comment that I'd put there. Here is more like, look, I'm just going to put this stuff here to make sure my main understands it. And also I'll have a list of functions there so that my human can look at it. My human. I'm talking like I'm not one. Don't worry, humans. I am one of you. Yes. Beep boop. List here so that humans can understand it. I still refer to humans like I'm not one of them again. Anyway, when the robot overlords take over, I will be the first to bow down and pledge my allegiance. I've said that before. Okay, so this will generally just be a list of functions, which is okay, it's good to see them, but in terms of the detail of what the function does, we put that with the rest of the detail usually. So Michael was elaborating on that. I used a lot of logical operators for the spiral program. Should I say these put the dashes and the asterisks in the right spots, or this is how they put in the right spots. It depends on how difficult you think it's going to be for someone to understand, Michael. So you can put information about it if you think it's going to be really hard to understand. It's like, this is the check for the dashes and the dots. This is the thing that does it based on this mathematical principle and stuff. But usually it's just like, this section does this function. You don't need to know exactly how in the comments. You just need to know that it does it. So it's usually more what than how in the comments. But I'm not gonna say there's a definite hard and fast rule, because sometimes something is so weird and complicated that you want to explain it. What I can suggest is, if you want to, in your tutorial or lab this week, have a chat with your tutor and say, all right, what do you think? And the funniest thing is they will give you a completely opposite answer to me, because comments are for humans, right? So they're going to be subjective. But I think it's good then, because then you'll see multiple different opinions and you'll say, all right, is there a way that I can comment this so that, oh, I have my notifications on by accident. I can't believe that notification on Slack shrunk my whole window. That was from Shrey as well. I'm not sure if he was sending me something that I needed for this chat right now, but I think he's gone. Anyway, where was I? I was here. Yeah, so commenting is always going to be a little bit subjective, but you might be able to find a way that the commenting works for both the way I like to look at it and the way your tutor likes to look at it. And if they're different, then you've found a way of commenting that works for multiple people, which is optimal. You know, that would be like the best. Okay, Masony is asking, having two of the int adds, the question, it was, would that mean you would need to define a function twice, having two of the int adds? So if I have this int add here, and I've got defined here and then declared here, you're asking if I need both of these, or yeah, this is a particular layout where this bit. So the question was, do I need to have this int add at the beginning as well as this int add here? If we only have this one, then the main function won't be able to call it because it won't know that it exists because it comes afterwards. If we wanted to, we could put the whole function up here, but putting the whole function up there means we're going to put a whole bunch of stuff before our main, and so it gets a bit fiddly and hard to see, which is why we put this thing here, which is just a framework for what the function's going to be. And so it says, this is what the function's going to be like. You don't need to know what the code is, you just need to know what it's going to be like so that you can call it. And then when you call it, the compiler will be able to jump around and find it and make it work. Compiler doesn't really jump around like that, but this will only be used when it runs, and when it runs, everything's already compiled. I'm not sure if I'm answering your question correctly, Masony, but hopefully that's giving you some more information. Sebastian said they had a question there. Oh, if we did printf %d and printf high, it would print... That's a really interesting question. I want to run this. I want to run this, because this is totally not something that I would usually do. Alright. I'm going to clear this. I'm going to make a new file. Get it. I'm going to call it printtest.c. Who was that? Sebastian. So we need our standard IO. And I've got this. And okay, so the question was, if we do printf, and we do a %d, and we match it up to a value, and the value that printf can be printf is actually a function that returns an integer. So if I do this, I have to admit, I'm going to admit that I've never done this before, because this freaks me out. But I think that this is legal C. So the way that this is going to work is it will evaluate this first, because it needs this thing to finish so that it can get its value as its output to put into here, and then it will run this. So I think that you are correct, Sebastian, in that the first thing it will do is it will print high. Let's just put a new line on this and a new line on this just to separate things. It will print high, and then it will output the number of characters that are printed, which should be 3. And that output, so after a function runs, it's nearly like after a function runs, this gets transformed into the output value. And if we take that assumption, because we don't know, because someone else wrote printf, but the assumption is printf will tell us how many characters are printed, it should transform into a 3. After it transforms into a 3, the 3 can match up with a %d. So we should see high, and then a new line, then 3, because I think this will be 3 characters rather than 2. And then the program will end. Let's see what happens. This is interesting. I always love this, right? Because I teach introductory programming. So it should be, it's not true, but it should be that I've done everything, and I'm showing you some of what I've done. But what I always love is when a student asks me something and I say, you know what, I've genuinely never done that before. So this is why I'm doing this one now, because it's like, it's super interesting because I'm not sure exactly what it will do. Print test. But I think it'll work. Yeah, it seems to be working. Because what I know formally of what C does, there's nothing wrong with this. We're just calling a function to get a result. That function happens to have a side effect, and then we're calling another function using what was the result of that function. Yep, there you go. So you were correct there that it would print out high and then 2. Mine turned into 3 just because I added a character, because I added the new line character from your code there. So super interesting. And this is hilariously confusing code. If we hadn't just done this in a lecture, this is the kind of code that would be really fun to put in an exam. Because it's so little code for people to look at. But this would be something that would really test whether people understand how functions work. Because you'd have to understand which one gets run first. Because this one can't get run first. Because it cannot put anything with that %d until this one's finished. So this one would have to run first. Evaluate. Turn itself into a number because the number is the output of the function, then that number gets matched there. But if this one has to run first and it does stuff to the terminal, then its effects should appear before this one's effects. Super, super interesting. Yeah, Masony, I can understand why you're confused. This is exactly why this would be a really good exam question. Because it would split the cohort into who can wrap their head around the idea that these things happen in a different order. So, let me show you what's happening here in a way that might be less confusing. I'm just going to use X because this doesn't have a particular... Oh no, wait. Num letters equals this printf, and this is num letters. This should show you a little bit easier what's happening because I haven't changed the order that these functions are called in here. They would be called in this order even if I left that printf there, but now I'm using a variable to be like this kind of go-between for the value. So, in order to get the value to match up with there, we had to run this function first. This function will print out high and a new line, but printf itself actually gives us output if we want to use it, telling us how many characters were printed. So, because this prints 3 characters, just remember the /n is a single character, that will assign a 3 to num letters, and then num letters will come in here and do this. Oh, Masony, this is a discussion that was happening, I think, between Shrey and someone else before, is that we haven't written printf. Someone else has written C as the language, wrote printf and wrote the standard library. Printf just happens to have an output, and that output is is the number of letters that happen to be printed out by that printf. You'll notice that a lot of the time when we use printf, we never assign it to a variable because we don't really need to record how many letters were printed out, so we don't bother with it. So it transforms itself into a number, then disappears. I'm sorry, that's not going to function until I put a new line on it. So usually when we printf, we're not trying to save the number of letters that were printed, but in this case we could use it if we want to. And so the more complicated example is to put the printf into there, and so this one line of code gets exceedingly complex. Unnecessarily exceedingly complex. But it gives us a bit of information about functions and their consequences, and also functions and their outputs, which are different things. Printf has consequences. The consequences are something appears here in the terminal, but it also has output. And output is what it transforms into in this position in the text of the program. So it transforms into a number here, and over here it creates these characters, right? So there's different things between the consequences of a function being run and the actual output of the function, which is the information it passes back when it returns. So this is like really, really kind of interesting. This is a really super question, Sebastian, because like I thought it was great because I looked at it and went, okay, theoretically I know exactly what this is going to do, but I need to test this because I'm not sure. So I think it was really fun. Okay. Other questions? Okay, so my answer to Wei worked. That's good. Mingji Li's asking, when we create a function, which is the input and which is the output? This is very specific and it will never change. Where's our function? Our function syntax here. The first type, so the very first thing of the function is its output. It's also known as the type of the function itself, because the function will transform itself into a value of that type when it runs. The stuff that's in the brackets are the inputs to the function, and there can be more than one. There can also be 0 inputs to a function. So I can run a function that just does the same thing every time, regardless of what information goes in, or actually doesn't take any information. So in the brackets is the inputs to the function. The function type is the output of the function. So it's always going to be the same. Max G said, I just did the second order 3 challenge. Took me longer than I'd like to admit. Can I use the same code for the other 2 order 3 ones? Yeah. So if you have the more complex solution, then you can use it for the simpler ones if you want to. That was what I was saying earlier, was the hyper challenge for order 3 is to not do it the easy way and only do it the hard way, because usually doing it the easy way, again, staged problem solving, if we do something the it's not stupid, but the simpler way first, it'll give us clues as to how we might do it the harder way. But if you've already done it the harder way, that obviously is going to work for the easier way. So you can do that if you want. Or you can rewrite them if you want to do it with a way that takes less effort. Up to you. Shayak is saying, can we complete the spiral with just whiles, ifs, and logical operators? Yes, you can. It is intended to be that way. Nothing in the challenges is ever intended to make you need to use anything I haven't taught yet. So there would be a way to do the spiral challenges using what I'm teaching you on Thursday, which is arrays, which is multiple collections of information, but there's no need to do that for that. It's really just you do a double loop to do a 2-dimensional output, and then for each cell in that output, for each character basically in that output, you decide what symbol it was going to be. which is the same way as like all of the simpler things that are in the tutorial this week, which is like we're just going to print out a 2D grid, but we're going to learn how to turn things on and off based on conditions. So the information we'd have for each cell in the 2D grid is the coordinates, and we use maths on those coordinates to decide which things are turned on and off. Spiral's the same, it's just more complicated maths. Echoing saying mysteries have been unveiled. I think that was after we did the this with the one-liner with the printf. Mason is, yeah, realizing at this point that yes, printf does actually return some information, but up until this point we'd never used it, because if I'd used the return information before, I would have had to explain functions, and we've been pretty chock-a-block with the lectures where I haven't had time, and I haven't really wanted to explain. I haven't wanted to expand all of the possibilities of what we can do all at once, so I've been expanding it slowly as we've been going along. Mason is saying, does that mean that technically we could write our own library and make it so instead of these predefined names, we can set it to something of our choice? Yes, we can. We will be looking at actually doing that around week 6 or 7, I think. We're going to talk about how to create our own projects with multiple files and how to include our own files in here and get access to them. And we're going to look at that in great detail when we get to, I think, week 8 or 9 as well, when we look at actually putting together nearly like a library package that you could import into something else. Not quite, but nearly. Jet is saying that be warned, autotest doesn't cover all possible combinations for order 3. Yes, yes, and that is important. That is a lesson in and of itself. Automated testing is never going to cover everything that you need. Automated testing written by humans is definitely never going to do that. It can cover a significant number of examples, but what you want to do is to try to make sure that the code that you write is correct regardless of what the tests are. And this is leading you towards the idea that in the future you will not have autotest. Autotest implies that someone else has done a whole lot of work for you, which we have. It does take a lot of work writing those autotests. When you get down to it, those autotests are tests that you have to write yourself. So in the real world, we will have an idea where it's like, okay, we need to do this kind of work. We need a program that does certain things. And so you'll look at that and say, okay, if it needs to do these certain things, here are the tests that I can write to do that. Autotest could be boiled down to something that says, if I give the program these inputs, I receive these outputs. And so you can write your own tests that says, okay, when I type in these things, I should get this result, you know? And there's actually ways to do that where you can actually sort of partially automate your own testing like that and see whether it works or not. So one of the interesting things, and we might do this, I was going to do this last time, but we didn't get enough time to really change it, is have questions, maybe challenge questions and stuff in the labs that don't have auto tests. Or even have things where we give you the whole program and you have to write tests. So you have to write the things that we were writing for the auto tests, sequence of inputs and outputs that show whether a program is working or not. So that could be really interesting. Actually think of that. A really interesting lab exercise I could give you is I can give you a piece of code that runs, or even a piece of code, a program that runs and not give you the piece of code. So I only give you one of these. So you don't even get to see what the code is. But I give you this that runs, and I tell you what it should and shouldn't do, and then you have to write tests that tell me, that show exactly the situations that this program works in and doesn't work in. That would be a really interesting lab exercise. I may actually write that. We'll see. We'll see if I get time to write that before the end of term, because I think that's something that that's really important for people to learn how to do. You know. So in 1511, we keep things pretty at a simple level because we're teaching you concepts that you've never seen before, like again and again and again through the course. We're just introducing things that no one's ever seen before. So it's harder for you to necessarily get on board with absolutely everything that I'm teaching you. But this could be really good, like trying to teach you how to make tests. Okay. Yes, so I was talking to Masony about that, which is talking about how, yeah, we can totally make our own files with things, and hopefully I'm helping Mingji Lee there. Yeah, so Mingji Lee says they've got it, and we're talking about Jet's thing there about autotest not covering everything. Catherine says, so this can only output integers. Yeah, this function here will only ever output integers. It cannot output anything other than an integer. It has been defined as such. So C is a language that is very, very careful about when it uses types. So if I say that a function is of a certain type, then it is absolutely that type only, and it will never do anything else. So this can't return anything other than an integer once we start using it. SK is saying, what are these cool beeping noises in the background? I'm not sure. Maybe traffic going past or something. Chicken's not in here right now, so she won't be doing beeping. I'm not sure. Shayek saying it's like the X problem but on steroids. That's exactly what it is. The X problem is trying to figure out how the arms on the X work. And the spiral is how to figure out where those spots are based on the maths of the coordinates and whether they should be on or off. Echoic is saying they spent an hour on the X problem, got really close, went to eat dinner, had an epiphany, came back, and in 10 minutes the whole thing worked. Echoic, you have discovered what it means to be a computer programmer. So this is something that I've taught before, and I may be teaching again. I'm not sure if we're going to do this. I was talking to Michael. He's not one of the current tutors, but he used to tutor for me. He's tutoring for one of the other subjects now. Works a lot with CSE-SOC. And he was saying that it'd be cool if I do another seminar in week 6, which is the flexibility week, so there's no classes then, so I've got time to do a little bit of extra teaching for people. One of the first things that I tell people when they can't solve a problem with their code is to get it away. Get it away from you. Get it off your screen. Go for a walk. Have a nap. Have a shower. Something else. Something else usually something that's at least a little bit physical that gets you away from your computing space. Because sometimes your subconscious is able to turn this program over much better than your conscious mind. Your conscious mind tends to get stuck on tracks. Like our ability to focus is both a blessing and a curse. Sometimes it's really good to focus on things. Sometimes that focus means that the solution to the problem's over here and we're stuck on this track. So yeah. So some of the best solutions to problems have happened when people have just put it away and gone and thought about something else for a while. The morning after thing is definitely a thing where you spend all day on a problem, you can't solve it, and then you go have a nap and you come back, or you go to sleep that night and you wake up the next day and you've solved it. This is usually for much bigger problems than we're doing in 1511, but the idea of a brain reset is definitely something that can help. So I like that you told that story, Echoic, because it really does make a difference. Okay, Alan O is asking, for this line, int total equals add first number, second number. What is the use of that total since we never use it again, and technically it wouldn't do anything in our compilation? Yeah, it's not doing anything. This is just an example. I mean, this is a dummy example to show that functions work. If I wanted to, I could then print out that total so at least have something happening. But for the moment, this int total, yeah, it would get compiled. It would have a piece of memory. That memory would get this number written into it, and then the program would just end, and that memory would get cleaned up. But this is an example so that later on, when you want to keep the output value of a function, you've got some code here that shows you how to do it. So yeah, the function itself has no, sorry, this variable itself won't ever be used for anything in this piece of code we've written. But this is just an example of how to use the code. So now you know how to assign a function output to a variable, so that in your own code, when you want to do this, you'll be able to do it for other things as well. So Catherine is saying, if you're defining a function that you would want to have decimal, you would write double at the beginning. Yes, very much so. So in the same way that we have types for variables, we can have types for functions, and the functions can be any type that we've seen. So for the moment, we've only seen int and double, but pretty soon we're going to be starting to add different different variable types. And once we've added different variable types, we can use them as the types of functions, definitely. Priya saying they like the idea that Twilight came to Stephanie Meyer in a dream. I also can understand that plenty of people would dream about stuff like Twilight, because it's like this amazing, fantastic world where everyone is beautiful. And I would also like everyone around me to be beautiful as well, and to be a teenage vampire or something. I'm not sure. Yeah. It's like, this is going down a weird path. Okay. I think I should wrap it up there. I'm making a habit now of these questions going for like half an hour, 40 minutes over time. Well, it's not over time, because this is just separate time for questions and stuff. But I think we've answered everyone's questions. So I will give everyone a moment now to ask their final question if they want to, and otherwise I will wrap it up here. So I'll just give it a sec for the lag to catch up. I'll just watch to see if there's any questions. No worries, Catherine, you're welcome. Okay, I think we're done. So if anyone has any further questions, talk to your tutors in your labs. There's plenty of time in the labs to ask questions. Questions on the forum are great. We love questions on the forum, because any questions you ask on the forum, we can answer them for the entire cohort, which is really wonderful. Like, that's the best way to answer a question, I find, because it goes out to the most people. Otherwise, we'll wrap it up there. Thank you all. Thank you for sticking around. I hope I answered all your questions. And I will see you all again in 2 days, where we will actually use these functions in a program, as well as some other stuff that we're doing. Yes, and Chicken loves you as well, Echoey. Chicken loves all of you. She doesn't know any of you, but she probably loves you. She's that kind of cat. All right. See you all.